This is the brief on mathematical invariance and tensor transformation. So what's this all about? The source material gets into a really core concept in physics. It proves that if a physical quantity stays constant, no matter how you shift your point of view, then the mathematical structure creating it must be a tensor. It has to follow a very specific set of rules. Okay, first, it all boils down to this idea called invariance. Think of a type 0-2 tensor like a machine. You put in two vectors, and it gives you back one single number, a scalar. The key rule is that this final number must stay the same, even if you completely change your coordinate system. Second, this need for a constant answer is what dictates how the tensor works. See, when you shift coordinates, the vector components change. So to keep the final output the same, the tensor's own components are forced to transform in a way that perfectly compensates. This invariance is the litmus test. It proves the structure is a tensor. And finally, this elegant compensation is the whole point of a tensor. Its transformation rules are designed to perfectly balance out the changes in the vectors. So while the individual numbers might shift, the physical reality they represent, like energy or curvature, remains unchanged. In the end, a type 0-2 tensor's defining property is its ability to hold on to physical reality, even when the framework we use to measure it shifts.